In this HVAC training video, I'm going over refrigerant bottle types found in HVAC. And so to give you a brief introduction, these are reusable recovery bottles. And over here we have disposable bottles. So these are one-time use bottles. So let's go ahead and start looking at these. Here we have the common disposable refrigerant bottle types used in air conditioning and heat pump systems. So the oldest refrigerant here is R-22. And this was phased out quite a while ago due to the ozone depletion potential. This one right here is now phased out. So R-410A is phased out due to the high global warming potential. And then over here are the new refrigerants that we have. These are the A2L refrigerants. So basically A2L means that they're slightly flammable. And so there's a red stripe, there's left-hand threads, and there's a pressure relief valve on the tank. And so pressure relief valves are also found on reusable recovery bottles as well. But these are here in case the tank overheats. It's going to let just a little bit of the refrigerant out so it doesn't burst, essentially. Over here on the A1 refrigerants, you have the burst disc. And so it would let all of the refrigerant out if it was to really overheat, because what happens is with refrigerants, when you increase the pressure, the temperature increases. And when you increase temperature, pressure increases. And that'll happen anytime that you have a saturated refrigerant in a tank. And so saturated means that both liquid and vapor exist in the same tank at the same time. And so this bottle's flipped upside down right now, right? And so if we want liquid to exit the bottle, we would have this flipped upside down just like this. And so there's going to be saturated refrigerant inside. You're going to have vapor up at the top and liquid in the tank. And as you use the refrigerant and put it into the system, you're going to have less and less liquid. And so once you only have vapor, you're no longer going to have this, what's called a pressure temperature correlation. And so there's a pressure temperature chart for every one of these refrigerants. So at a certain temperature, such as say 70 degrees, R-410A is going to be say 201 PSI. And so it's always going to be like that anytime that you have saturated refrigerant in the bottle. What I wanted to get at here is that these two, even though they're A2L, which means mildly flammable, there's no flammable refrigerants inside. So there's no, say, R-290, which is propane. There is nothing like that inside. So R-32 is simply R-32. That's a single component refrigerant. R-32 has been used in R-410A. And so 50% of this bottle is R-32, and the other 50% is R-125. And so this is a blend refrigerant, whereas R-22 is a single component, R-32 is a single component, R-410A is a blend, and so is R-454B. This is a blend. And so this one has R-32, it has 68.9% R-32 and 31.1% of R-1234YF. And so it's a blend refrigerant. Anytime you have a blend refrigerant, the refrigerant must exit the bottle as a liquid. So you have to flip this bottle upside down to charge with it. When you have a single component refrigerant such as R-22 or R-32, it can be charged as a vapor coming out of the bottle, or you could flip the bottle upside down and charge as a liquid. So for instance, if you vacuum a system down, so it's an empty system, you've pressure tested it, you vacuumed it, you're going to break the vacuum with liquid refrigerant from the bottle, regardless of whether it's a single component or a blend refrigerant, in order to quickly charge the refrigerant into the system. And so if you fixed a leak on the unit and recovered all the refrigerant out, there's nothing there. So you may have to charge, say, 5 pounds from the bottle into the system when you're breaking the vacuum. So that's when the system is off. If you are charging while the system is running, then what you're going to want to do is you're going to want to, for these blend refrigerants where it has to come out as a liquid, you need to protect the compressor by only allowing a little bit of liquid refrigerant out at a time, because you have to get it to basically become saturated where liquid and vapor exist. You don't want to slug the refrigerant compressor in the outdoor unit, so you could use something like this, which is a charging adapter. It's a tiny little pinhole. And so it takes the liquid out of the bottom of the tank and flashes it into a saturated mix of both liquid and vapor. And so by the time it gets over to the system, maybe through your refrigerant hose, it's going to be mainly in the vapor state. But if you're charging refrigerant into a running system, when you're adding, say, R-32 or R-22, you can just charge it as a vapor, just a little at a time, and that's fine. Remember, the refrigerant compressor breathes vapor only. You should only have vapor entering it. If you ever have, say, liquid entering it, you're adding a non-compressible into a compressor. And you're also washing the oil away from the inside moving part. So that's not good. Anyway, we do have other videos in reference to the ozone depletion potential and GWP and things like that, the reasons why we switch from this to this and now from this to these two. So you can check that out in the description section below. But what I want to tell you is that, all 4 of these tanks look like they're the same size, right? But this tank, R-22, has 30 pounds of refrigerant inside, whereas a new R-410A bottle has 25 pounds of refrigerant inside. And these newest A2L refrigerants, these ones have 20 pounds of refrigerant inside. And part of the reason for that is that density is different. So any type of tank is, you figure the liquid capacity for a tank, you compare it to water. And so at 77 degrees, R-22 has this specific gravity compared to water, like liquid water. It's 1.195 times more dense than water. R-410A is 1.062 times more dense than water. So these two are more dense than water. These two are less dense than water at 77 degrees. So for R-32, it's 0.964 times less dense than water. And for R-454B, it's 0.988 times less dense than water. So anyway, the long and short of it is that the same amount of liquid refrigerant over here weighs less than the same volume of refrigerant with these refrigerants. And so you just want to be aware of that for when you're buying these new refrigerants. And of course, we always use a refrigerant scale when we're charging refrigerant into a system, because you have to basically charge the building owner, the system owner, based on the amount of refrigerant you're charging into the system. So you got to remember, you only have 20 pounds of this, and that's it. So it's fairly expensive for the R-454B refrigerant. Okay. The other thing is, with these left-hand threads, you're going to want a left-hand thread adapter. And so you'd use an adapter like this, because normal refrigerant hoses can't screw onto this. It's just a reminder that these are A2L refrigerants. That's the whole point. That's the point of the red stripe and the left-hand threads. The other thing is, some manufacturers make a left-hand adapter on their hose, so it screws right onto the bottle without having to have an extra adapter on there. Because you got to remember, if you add a left-hand to right-hand thread adapter and then you screw on a right-hand threaded hose, you have opposing forces, right? When you're trying to tighten this on, this one's loosening, and so you got to make sure that they're both snug. And if this bottle is flipped upside down, like so this one right here, so it has to be flipped upside down when you're charging refrigerant out of it, it can become loose, and you don't want that. You want to have a tight fitting here, so you might want to use a hose that already has the left-hand adapter on it. The other thing that I get asked a lot is about the colors. And so refrigerant bottles as a whole don't have to have color designations anymore for the new refrigerant bottles. And so they're just labeled with the type of refrigerant inside. Now, back when we had color designations like light green, and this was pink or light rose, and this meant it's R-410A. But there is so many refrigerants out there that they ran out of colors and ran out of adjustments of colors. So that's why we're just having them printed on the side of the bottles, and that's really it. That's what we're working with now. Now, anytime that we're measuring pressure or we're adjusting refrigerant charge on the system, you want to wear either, say, nitrile gloves or butyl line gloves, because you don't want to have any of the chemical getting absorbed into your skin as well. It can, like as the refrigerant exits the bottle, you got to think it's at a certain pressure, right? And then it comes out and it's low pressure. So what happens is it flashes, it lowers in temperature. So if there's a pressure temperature correlation and it comes to a low pressure area, it's going to lower in temperature. And so you want to avoid your fingers getting into contact with that low temperature refrigerant exiting the bottle. Now, we do use a valve on the end of our hoses, so we don't want to be using a hose that does not have a valve, because all of this refrigerant is going to be exiting the hose. And so it's going to be exiting where you're disconnecting at. So you don't want that. So I highly recommend having these manual low loss valves built onto the hoses. You know, you can add them like this onto the end of the hose, but I like them when they're built on. And so when you're getting ready to disconnect the hose from the port, basically you just turn this to the off position and then you would unscrew this. And you just make sure that you have your gloves on in order to protect yourself. It's important to note that before working with any type of refrigerant, you need to get EPA 608 certified. So for instance, to work on, say, residential, light commercial air conditioning and heat pump systems, you need a Type 2 EPA 608 certification. So you'd have to pass, say, 25 questions on the core and 25 questions on the Type 2. If you wanted to get a Type 1 certification to work on, say, smaller systems like package units, like a refrigerator, that would be a Type 1 certification. And if you want to work on low pressure, larger commercial units, you'd need a Type 3 certification, or you could just get a universal EPA 608 certification that'll handle working with any type of refrigerant on the market. And before working with these refrigerants out in the field, you want to make sure that you're working with a licensed contractor to show you how to safely work with these refrigerants. You want to make sure that you have your safety glasses on. You want to make sure that you have fresh air available, like where you're working at, and make sure you're wearing nitrile or butyl lined gloves so you don't get any chemicals on your skin. Here we have disposable refrigerant bottles with less than 1 pound of refrigerant in each. And so these are actually highly flammable refrigerants. This is an A3 refrigerant. It's R-290, and that's known as propane, right? So it's just a more purified version of propane compared to what is in your, say, your gas grill. And this one right here is R-600A, that's isobutane. And so the most effective and efficient refrigerants for heat transfer are either highly corrosive or highly flammable. And so these are A3, highly flammable. The other thing is the global warming potential of R-290 is only 3. That's it, 3 GWP. And so they're trying to find uses for these highly flammable refrigerants in, say, heat pumps and air conditioning systems. And so the reason that we haven't got there yet is due to the regulations. And if you were to have a leak inside the building, you don't want a flammability concern inside the building. But these are presently used in, say, refrigerators and chest freezers, things that don't have a whole lot of refrigerant inside. So if they did leak, say, the 3 or 4 ounces that they had out of the system, it would dissipate with the air in the room. And so there wouldn't be necessarily a flammability concern there. And so that's why these are in smaller, say, 14-ounce bottle like this, or 14.8 ounce bottle here. So you don't need a whole lot of refrigerant in order to charge these small systems. And so you're going to need a valve. They don't come with a valve on the bottle. And so you want to make sure that this is in the open position before you screw it on. Now, the other thing is you want to make sure if you have a valve core in the port here or you don't. So this one does not. And so what I like to do is I like to have the hose attached on before I even screw it in. And you're also going to notice that we're using a very short hose here. It's only a 2-foot hose because we don't want to lose a bunch of refrigerant in the hose when we're, say, breaking the vacuum with refrigerant from the bottle into, say, a refrigerator. So we don't want to use a 5-foot hose. We just use, say, a 2-foot hose. However, we do want some type of a manual valve on the end of the hose in order to control the charge as we're charging, because these systems that we're adding this refrigerant into are critically charged. That means they have to have exactly the amount of refrigerant that's needed in them. So it can't be accidentally overcharged. And so what I like to do is I like to just kind of hold the valve assembly and then just spin the bottle. And so in order to screw this in, and you'd want to make sure, have your gloves and everything, your safety glasses on ahead of time, and you want to make sure to have your valve in the off position. And so if you want liquid in the hose, you would need to flip this upside down, and then you would need to open the bottle right here, and you would need to purge any air out of the hose so you have liquid refrigerant right at the end here before you would set this on the scale. And you'd need to kind of isolate the hose to make sure that the hose doesn't move and change the weight on the scale before you break that vacuum with the exact amount of refrigerant needed, which may only be a few ounces, and that's it. So that's why these are very small, and they can come in larger bottles, but we typically don't need a lot presently when we're charging and fixing a leak in a refrigerator and recharging that system. These are what's referred to as reusable recovery bottles, and so we get these empty from the distributor with maybe nitrogen inside or maybe no pressure at all. And what we need to do is we need to vacuum these, get all the water vapor out, get any air out before trying to take refrigerant from a system, recover it, and put it into these reusable recovery bottles. And so we pull it down below 500 microns, and then we break the vacuum with refrigerant from another bottle or from the system we are recovering from. You do not want to transport these under vacuum. They're not going to hold a vacuum. These valves are not meant to be under vacuum at all. They're only meant to hold pressure. And even then, I've seen some tanks, they leak. It's not good. Anyway, this one's cut open so you can see the inside. There's a dip tube on this side, and that's connected to this red handle right here. The blue handle is just attached right to the top. And so what you really want to pay attention to is less on the colors and more on the word. So this says vapor on it. And so the vapor is attached to the top of the tank, because as you fill this recovery bottle, it's going to have more and more liquid on the inside, and your vapor will be up at the top. This dip tube on the liquid side goes all the way down to the bottom, all the way down to almost the very, very bottom. The issue is we have some recovery bottles out there that have the wrong colors on the handles. So you really need to be careful with that. But a lot of times we're just recovering right into this vapor port. And some people even flip the bottle upside down as they're recovering and put it right into the vapor side. So it just depends on, how effective your recovery machine is. But the biggest thing is we need to prepare these bottles and make sure that we don't get any air into the bottle, because if you have air mixed with the refrigerant you're trying to put in, you're going to have excessively high pressure. And so like your recovery machine might not even be able to push that high of a pressure into the bottle. So you want to make sure that you're only recovering one type of refrigerant into that bottle. So you could recover like multiple systems as long as all of them had R-22 in them. So you could put one charge on top of the next, on top of the next, as long as they're the same refrigerant, R-22. So you want to have your tanks labeled, especially now that we have refrigerants that have similar pressure temperature correlations for the saturated refrigerant. It was pretty easy before if you didn't have a tank denoted and you wanted to know if it was R-22 or R-410A, because at 70 degrees, the pressure would be, say, 121 psi if it was R-22, but at 70 degrees for R-410A, it's 201 psi. And so you could tell the difference between the two. The other thing is there's some replacement R-22 refrigerants out there, like drop-in refrigerants like MO99 or R-454B that had similar pressure temperature correlations as well. R-407C, which uses the POE oil, that had similar pressure temperature correlations. So now with R-410A, we have R-32 and R-454B that have similar pressures and temperatures. And speaking of that, this bottle is specifically designed for A2L refrigerants. It has left-hand threads. It has the red stripe, but you might not be able to get your hands on these bottles right now. It just depends. So if you need to recover an A2L refrigerant, you would mark it with the type of refrigerant that you're recovering, put the red stripe on, and that's basically what you would do. But on here, you'd need a left-hand, right-hand thread adapter in order to put onto the ports right there. If you were recovering refrigerant out of a single system and you wanted to reuse that refrigerant, you could reuse the refrigerant, but I wouldn't advise necessarily reusing refrigerant out of a used bottle, because like at the distributor, they don't clean the inside of the bottles. So you have like old oil from like compressor burnouts and stuff like that in these tanks. When you get like a tank that's empty from a distributor, it doesn't mean it's new. It's just a used tank that somebody else has exchanged, but now it's empty. And so you could have these contaminants in the bottom. You don't want to charge that back into a new system again. So the EPA 608 says that we can basically recover refrigerant out of a system and charge it back into the same owner's system. So we could do that, but I would prefer to use the virgin refrigerant out of a new refrigerant bottle if we're going to go to all this work in order to do that. Anyway, the other thing is we would exchange these refrigerants at the distributor, and if we had air mixed with the refrigerant, they might think that the refrigerant charge is contaminated. We want to make sure that we don't get any air into the recovery tank. We would need to, say, purge the hoses or vacuum the recovery hose setup before recovering refrigerant into a tank. Anytime you get air in the tank, it's going to always measure a higher pressure compared to saturated temperature. The other thing is that recovery machine might go off on high limit. It's not going to be able to push the refrigerant in here if you have a lot of air in here, because the pressure in the tank will be too high to overcome by the recovery machine. So just keep those types of things in mind. In reference to where you connect on the tank, as far as the dip tube is concerned, or the vapor side, a lot of times with residential like commercial systems, we're just attaching right into the vapor side, because as we're recovering refrigerant, it's saturated, it goes into the recovery machine, and you might be able to condense it completely into a liquid, but halfway through you're going to be recovering saturated refrigerant out of that system, and then towards the end, when the pressures get lower on the system you're recovering vapor. And so even if you have a good condenser in your recovery machine, you're still putting it into the tank as a vapor. So vapor saturated refrigerant. So you could recover it into the dip tube and come down here, and then you're going to be bubbling any vapor up through the liquid into the vapor section. Some people like to recover the refrigerant if they have a really good recovery machine and it condenses very well, and it puts it in as a liquid. They like to flip this upside down and use the blue handle port and dump the liquid right into the bottom of the tank right here. Some tanks have like a little clean out plug and some do not. Like this one does not have a clean out plug in it. Because this is for A2L refrigerants, it has the pressure relief on the back. I mean, any type of recovery bottle is going to have a pressure relief on the back regardless. But this one has the left-hand threads and the red stripe on it to indicate A2L refrigerants. Whereas these are your standard tanks. And so your standard, any type of recovery tank is going to have a gray body and a yellow neck. So it's gray and yellow. Those are the colors. And so some may just have like a gray bottle with like a yellow plastic on it or something like that. In reference to filling a recovery bottle, so it's referred to as a recovery bottle, recovery tank, whatever that may be, we're going to weigh the total recovery tank weight. And so we would zero the scale out first, turn it on, zero it out, and then put the bottle on. We're going to make sure to not overfill the bottle, and in order to do that, we need to compare the refrigerant to liquid water, and the way we do that is with specific gravity. So on the neck up here, there is a water capacity on the neck. There's also a tare weight. So water capacity is the full amount of, say, liquid water that you could fill in the tank, and of course we're not using water, they're just using it, the manufacturer's using it for calculation purposes. Tare weight is the empty tank weight. And so what we do to make sure that we're only filling this up to, say, 80% or less of the liquid capacity worth of refrigerant, we take the water capacity times 0.8, that's 80%, and then we times that by the refrigerant specific gravity. After we calculate that, we add the tare weight. That's going to be the max bottle weight that we're allowed to have. And so we would just monitor that as we're recovering refrigerant. And before we recover, we would just check the factory charge in the system. And we'd also look at how long the line set is, just to determine, hey, are we going to overfill the bottle here? So you could kind of fill the bottle to 80% and then switch it out, put another bottle in, and keep recovering. Let's take this to a practical example of filling a recovery bottle to 80% of its capacity. So that's called the max weight. So the first thing you need to do is find a recovery bottle that doesn't have a giant hole in the front. And you want to make sure that you have the bottle prepped, it's vacuumed, and you broke the vacuum with refrigerant from, say, a system or from a bottle. You have a tag on the side of the tank, and in this case, we're going to go with R-410A. And so then you need to look at the neck of the bottle and see your water capacity and tare weight. So you'll take the water capacity times 0.8, and then you take that times the specific gravity, and we're going to use a specific gravity at 120 degrees for R-410A. So say it's hot outside, and the refrigerant exiting the recovery machine is high in temperature. So we're going to use that figure for our R-410A refrigerant. So you take that, you add your tare weight, and that's going to give you the max weight. So let's go step by step through this. So we got a water capacity of 26.5. We multiply that by 0.8, and so that equals 21.2. Take 21.2 times the specific gravity of R-410A at 120 degrees, and so that's 21.2 times 0.926, and so we equal 19.63. So then we take 19.63 plus the tare weight, which is 16 pounds, and we equal 35.63. So that's the amount of pounds as your max weight that you should have. So if you put this onto the scale and you have, say, 20 pounds, then that means that you have 15.63 more pounds of refrigerant left in the tank that you can add in, and you would compare that to, say, the factory charge on the outdoor unit and see if it has excessive line set length, or if it's just a short line set, it might just be the amount that the factory charges. And so you would just go ahead and monitor the scale as you're recovering. So I hope this video on refrigerants and refrigerant bottles has helped. And if you want to learn more about HVAC, especially refrigerant charging and installing a system, pressure testing it, vacuuming it, breaking the vacuum with refrigerant from the bottle or from the system, charging refrigerant into running air conditioning systems, a system recovery, airflow measurements, troubleshooting, and more, make sure to check out our new 2nd edition Refrigerant Charging and Service Procedures for Air Conditioning book. So we've got a full outline that you can check out over at acservicetech.com, and the book's available over at Amazon, True Tech Tools, and at acservicetech.com. Hope you enjoyed yourself. We'll see you next time at AC Service Tech channel.